Hi there, algebra students. This is Mrs. Grafe. I am doing my video. If you missed class today, or if you just want to review the information I went over on our Zoom chat today, it's so amazing to have so many of you come in and value your learning. And hopefully, if you're watching this again, it will make more sense. If you're watching this for the first time, because I know a couple people weren't on with us, good for you. Way to do what you need to do. So what we're looking at here is just kind of doing something I found on the news yesterday, and I found two amazing graphs which mathematicians helped our government to figure out, so we could gather data about corona and how many people it might affect, and how we can save lives. So this first graph is titled cumulative cases per 100,000, meaning this over here, this y-axis is labeled from 0 to 400,000. And then over here we have a key for all 50 states, so it is difficult to see which curve is whom. But as they talked about on the news, I picked up that this is definitely New York. That is where we have the most cases. And as you can see, we have about 350,000 cases of corona. And that's a huge number, and that's a huge number for our hospitals to deal with if people are that sick and need to be on ventilators. So that is why right around this date around here, mid-March, almost mid-March, we started to quarantine people across the United States to make sure no other states would reflect this exponential curve. You guys might not know that, but because I've studied mathematics in college as well, this is an exponential curve. And luckily, all of these other states have stayed way below New York's, and even this is the state of Washington's. And that is because of our what is called mitigation or our quarantine. So that leads us to our second slide. Let's take a peek. Our second slide was another slide that they showed on the news. So please be watching the news, figure out what's going on. Here we have goals of community mitigation. So look at the dark blue curve. This would be what mathematicians suspect would happen if we didn't quarantine. So we got this data based upon what's going on in Italy, South Korea, I believe, and I'm forgetting the third place. But we got this data from other places that had corona before we had it to a large degree. So if we did nothing, we didn't quarantine, we didn't do mitigation, we are looking at over 1 million people dying for sure. And that's a major thing, because think about, that's not even considering how many people are sick. We're talking over 1 million people dying from this. So the whole reason we did mitigation was to actually come up with more of a curve like this. So hopefully, due to you quarantining, staying safe, safe distancing, we will only have at most, let's hope, 250,000 deaths. Still a lot, but much better than what it would be. So please stay safe, guys. Stay at home, safe distance, and I'll get through this. So now let's get to the algebra kiddos. Let's get to some of the math we had today. And I'm not going to go on here, but you can definitely go on my lesson plans, because there's post work to what I'm about to do in this video. But the video is one of the first things you want to do in case you're struggling or you need help. And one of the things I asked as we did this was kids to chat about explaining one aspect of how graphing a linear inequality is different than graphing a linear equation. So think about that. Specifically, how is graphing a linear inequality different than graphing a linear equation? Well, I'm going to use our first example to highlight that. In 966, in some of our pre-work, you were to graph y is greater than or equal to negative 2x plus 3. And when you graph that, the two big differences is that sometimes the line is either solid or dashed, and we need to pay attention to where do we need to shade. Well, in this case, the line is solid because y is greater than or equal to. When it's equal to, all the points on this inequality will make the line true, so we make it solid. We need to shade above because we're talking any values greater than y, so anything greater than y is going above or to the right of this line. And if I test the point 0, 5, which 0, 5 is right in here, when I put 0, 5 into my inequality and actually do some math to support my reasoning, I end up getting 5 is greater than, oops, sorry, you can't see all that. That's a little bit outside of your view. I'm going to move this over So you can see that. There you go. Now you should be able to see I input 0, 5, and I eventually got 5 is greater than or equal to 3. So that supports where I shaded. In 567, since this is now a solid line versus a moment ago, we had, oh, no, big difference was here. It was y is greater than or equal to. This is now y is less than or equal to because we shaded on this left side, which is below. The y values are below or to the left of the line. And we got y is less than or equal to negative 2x plus 3. So that is the inequality that goes along. Well, in part B, Heidi asks, what if I change the inequality to y is less than negative 2x plus 3? Well, someone gave an answer in one of my classes that would make this a dashed line, and that is 100% correct. Instead of being a solid line, I am showing now for Heidi, what Heidi suggested, this would be a dashed line because 0, 3 would give us 3 is less than 3, and 3 is not less than 3, so we need a dashed line instead of a solid. If for some reason you missed it or it's not making sense, rewind my video and watch it over again. Listen to what I had to say over again, and hopefully I'm not making any accidental mistakes along the way, but no one's perfect. Now, I was hoping to have some kids share screen at this point, but unfortunately I was running out of time, so I'm just going to go over the answers. Here, we had the inequality y is greater than a negative 1/3 x, which makes a decreasing line, minus 1. It is definitely dashed because y is greater than. If I put in 0, negative 1, I get negative 1 there. I'd get negative 1 is, and I don't think this is what I was doing here, but I get negative 1 is not greater than negative 1, and that is false. So that's why the line is dashed. I'll just note that here. That's why our line is dashed. Okay. And then I would shade above, because if I test something like 0, 0 into my inequality to see, do I get something that's true or false, I would get 0 is greater than negative 1, and 0 is greater than negative 1, so we shade above our line. And I'll just show you the other 3 answers here. B, solid line, because y is less than 4x plus 2, which is a steep increasing line. If I put in 0, 0, I get 0 is less than or equal to 2, so that makes me shade to the right or below for those y values. For C, y is less than 5 over 2x plus 3. It is a dashed line because if I put any values in from the line, I would get 3 is, sorry there, 3 is less than 3, and that is false. So that is a dashed line because that statement is false. One more time. And then if I tested 0, 0, because that's the easiest point to test, always go for what's easy. I get 0 is less than, and hope you know 0 is less than 3, and that is true, so that's where we shade to the right. And then D is probably the trickiest. And D's inequality is the trickiest because you needed to put this in y is greater than, in this case, or equal to mx plus b form. And you will be doing this on the worksheet. You will have to go through these steps on the follow-up worksheet that you're doing for today. And I did have a mistake here. I had a dash line at first. You might even get to see it a little bit still, but kids reminded me, oh no, that's a greater than or equal to, Mrs. Grafe. You have to have a solid line. So I love that I made an accidental mistake and that people were on their toes and were able to correct me. And then we do shade to the left. So I think that concludes my video. Make sure you go onto the lesson plans and do the post work. I appreciate you either tuning in for the first time or second time, and be sure to email me then your 6 problems. Take a photo, email it to me, and I'll try to give you, a little bit of feedback to how you did via email. All right, you guys are awesome. Stay safe, and I'll hope to see you today at 3 p.m. for a fun Zoom activity we'll do every Wednesday at 3 p.m. See you then. Bye-bye.